This is homework number 7 lecture. Here we're going over percent applications. This is a relatively shorter section in comparison to the rest of them that we've done. This builds on top of what we learned in number 6 when we talked about a lot of percentage applications with yield percent. We talked about food cost percentage and some tax commission stuff. So we're putting all of this together in this percent applications and how to make use of all of it, how to put a word problem together and make an understanding out of the solution. So I'm going to go by the homework problems. I picked a couple that are within your homework assignment that relate to other ones. This way you can use them as a reference. But a lot of this takes critical thinking in order to understand. That's what I'm going to help y'all with as we do these problems. So let's look at number 1. Now, I'm not going to write the whole problem out, but read it out and write down key information. It says, under Todd's new cable television plan, his bill averages $75 per month. This is 150% of his average monthly bill, 150% from last year when he had the basic cable package. What was his average monthly cable bill last year? So when we see like 150%, notice it's above 100. We always want to understand that if it's greater than 100%, that's going to be some kind of increase. Whereas if it's less than 100%, it's going to be some kind of decrease in the fraction. So since it says 150%, what it's saying is it's saying 100% plus 50% more, and that would be 150%. So his new bill includes the 100% he was paying plus 50% more of his original one. And that's what we're going to figure out here. So what we can do is use that understanding of the 150% that I showed y'all last time. What we can do is say, all right, this can represent, we'll say X can represent his last year's bill times 1.5 should equal $75. Right here, this is the 150% of it was last year's bill. So this is last year. And then this is his new total. His new cost. So we're saying this is 150% of last year's monthly cost. And that's an algebraic expression that we can use, or an algebraic equation. We have it set up. We can say 1.5x equals 75. So to find out what his cost was, we can divide both sides by 1.5. And that would end up giving us x equals $50. So he ended up paying $50 last year for his basic cable package. So let's put it in terms of like this understanding right here. 100% of his cost is $50. 50% of his cost would be 50% of $50. So 50% of $50 is going to be $25. So that'd be $25 more. That in fact does equal $75. That's what we think of. The 100% is his original payment. 50% represents half of it, and that would then make the $75. That's what we say when we say 150%. 100% of the price plus half of the original price. So again, if you had 100% of, we'll just say, how about $200? If we had a plus 50%, that'd be plus $100, because that's half of 200. That would equal 300, which would be the 150%. So another example that illustrates that. So using these percent applications in that manner is an easier way of doing it and solving this problem. You could have also done a proportion for that problem. You could have said x over 100 equals 75 over 150, where this is your 150%, this is your 100%. $75 is related to 150%. We have to figure out what amount is related to 100%. And you could have cross multiplied. You get 150x equals 7500 divided by 150 on both sides, you would have ended up getting the same exact answer. So either or, the proportion works as well. It's an easy way to set it up. I worded it this way to help you see visually like what is happening with percentages and how do they work so that we can better understand them. So let's go to another one that's like this. Let's do number 3. It says Malia bought a new mountain bike. The sales tax in her province is 5%. So 5% sales tax. And she paid $61.50 in tax. $61.50 in tax. What was the price of the mountain bike before the tax? So it wants to know the price of the mountain bike. Remember, tax is based off of whatever you purchase. So it would be your X, that would be your purchase, times the sales tax, which would be 0.05. That'd be your sales tax. And that should equal your tax, which is $61.50. That's what the formula looks like. Take your purchase times tax rate equals how much you pay in tax. Again, we would do the algebra for this. 61.50. You just got to divide both sides by 0.05. Don't forget about the 0.05 on both sides. As we get as X equals $1,230. That's all there is to it. So setting up your percentage problem in this manner, again, I find is a little more helpful. We can figure out what's going on algebraically and how we do it in real life. We always set up things like this when we're talking about finding tax. So that's 2 tax and percentage related problems, but let's do something a bit more food oriented, which talks about yield percentage. So number 7. You purchase 35 pounds of kiwi fruit. So 35 pounds of kiwi fruit. And it has a yield percentage of 84.4%. Remember, that's how much we'll end up having left over is 84.4%. So we won't have 100% of the kiwi left over. It says you plan to divide the kiwi fruit into 1/4 pound portions. We want 1/4 pound portions. How many whole portions will you get? So how many whole, and that's the key thing, whole portions will we get out of this? So what we want to do is attack and figure out what we have. Remember, these 1/4 portions, 1/4 pound portions, are the prepped kiwi fruit. So we have to figure out how many that we have, how many pounds of kiwi fruit we can have prepped. So we take our 35 pounds. Remember, to find our EP, we multiply by our yield percentage. So it'd be your AP times the yield percentage will give you your edible portion. So as purchased times your yield equals your edible portion. Our as purchased is 35 pounds. Our yield percentage is 84.4. As a decimal, that's 0.844. Multiply those out, 35 times 0.844. That ends up giving us 29.54 pounds. So that's how much kiwi fruit we have in terms of edible portions. So that's how much we have total for the whole recipe or whatever we're making. Now we have to figure out how many 1/4 pound portions that gives us. So we don't divide this by 4 because that would be every 4 pound portions. We want to multiply it by 1/4, or you can not multiply by 1/4. You can multiply it by 4 or divide it by 1/4. So if I say 29.54 pounds divided by 1/4 pounds, we can rewrite that as 29.54 pounds times 4 pounds. And that makes it a little easier for us to understand it because remember, a 1/4 pound is a quarter of a pound. We have 29 pounds worth. We multiply it by 4 because there's 4 portions within each pound. So it'd be 4 pounds is what we multiply it by. And we end up getting 29.54 times 4. That gives us 118.16 portions. And that would be our answer. Now it asks for whole portions. So whole portions, we'd have to round down to 118 portions. And that would be our final answer. So what we do is we take what we have to find the EP of it, take that and divide it into our 1/4 pound portions. Now, if dividing by 1/4 is a little confusing, remember you can divide by 0.25 instead. 0.25 is the decimal equivalent of 1/4, and you end up getting the same answer for that. So you'll get the same exact answer. So that one, we take what we know and what we want, and we want to figure out what we have to get in the end. Now, if we wanted to set this up in terms of a bridge method, which we've been working on, and change it to the blue, we can do that. We can say 29.54 pounds. Remember, we want portions as our end result, as our end answer. So we're going to multiply by, remember, it's 1/4 pound is equal to 1 portion. That's our goal. So we can use this equivalency to figure it out. We put pounds on the bottom and then portions up on top. Pounds would cancel out, and that would end up giving us the about equals 118 portions. That's how you would set up mathematically with the bridge method, which you can use. You don't necessarily have to use it in this instance, but you can see that unit conversion-wise, it works. Here, I was trying to visually represent it, but you can't see how it changes the portions. Here, you can see how it changes to portions. So the key thing for a lot of these problems is writing down all the information you need at the very top. This way you don't have to look back at the word problem or anything. Just look at all the information you have and enter it in one by one, and then use that for all of your math that you have here, all your scratch work. Then you'll have a method and a procedure for finding it. You got to find the EP first, then you got to find the portions afterwards. So let's try number 9. It says you purchase bananas to make banana caramel cakes. Didn't say how many bananas yet. After peeling the bananas, you had enough clean mashed bananas to make 3 cakes. So you could make 3 cakes, and each requires 2.75 pounds of mashed bananas. I have to say mashed bananas. If the bananas had a yield percentage of 68.75, so the yield percentage is 68.75%, how many pounds of bananas did you originally purchase to make the cakes? So how many pounds of bananas did we have to make the cakes? So let's analyze what we have so far. It says we made 3 cakes and each required 2.75 pounds. So that means our EP is supposed to be 2.75 pounds per cake. So each cake uses 2.75 pounds. We have our yield percentage, which is 68.75%. It's asking how many pounds of bananas we need to find our total AP, our as purchased. So in order to do that, we first need to find our total EP, right? You can't remember this 2.75 pounds represents per cake. We have 3 cakes. So if we say 2.75 pounds times 3 cakes. 2.75 times 3 gives us 8.25 pounds total. And this is our EP weight. Now, whenever we're trying to find EP, we always multiply our AP by our yield. Remember, we always say AP times yield percentage equals EP. So we can plug in what we have. We don't have our AP currently. So our AP we can call it X times our yield percentage, which is 0.6875, and our EP total is 8.25. In order to solve for our X, we have to divide by 0.6875. And we divide by the decimal because when we divide by the decimal, it ends up giving us a larger number. We end up getting X equals 12 pounds. And that would be our answer. Our AP is equal to 12 pounds of bananas. And that's how much we had to buy to make the 3 cakes at 2.75 pounds of mashed bananas. So again, breaking things down piece by piece logically is how we work with this. You have to look for little mistakes like don't use 2.75 in your math. You have 3 cakes, so you have to have a total EP first. This would be your total EP. Then you can find your total AP. Yes, you could figure out what is the AP per cake, hypothetically. If you want to do if you want to do 12 pounds divided by 3 cakes, that would end up giving you 4 pounds per cake in terms of AP. But it wants to know the total. It doesn't care about each cake, but now you know per cake is 4 pounds. So there's a lot of different information you can find out with each and every one of these problems. Okay, so let's check out number 10. This one says you purchased a 50 pound case of persimmons. It says persimmons have a yield percentage of 82%. How many 4-ounce servings of persimmons can you get from the case? So how many 4-ounce servings can we get from the case? So here we can go ahead and figure out what our EP volume is, or EP weight is. So we have 50 pounds of persimmons multiplied by 0.82. 50 times 0.82 ends up giving us 41 pounds. So this is our edible portion. Now we have to figure out how many 4-ounce servings. And if the math confuses you, like do I multiply by 4? Do I divide by 4? What do I have to do? Notice it says 4-ounce servings as well. It says ounces. It doesn't say pounds. We have to do a bunch of conversions. Here I think the bridge method is easier because then you can set it up again in an Excel spreadsheet pretty easily. Take the 41 pounds. First change it to ounces. For every 1 pound, you have 16 ounces. Then, for every 4 ounces, we have 1 serving. So there's 4-ounce servings. That can give us our total amount because our pounds cancel out, our ounces cancel out, and we're left with servings. 41 times 16 gives us 656 for the top number and 4 for the bottom number, which then gives us 164 servings total. So there I prefer the bridge method. I mean, you could use the bridge method on some previous problems as well. But this way is pretty nice. I liked it because it does all the conversions really nicely and easily, and you can just see everything happening. Pounds to ounces, ounces to servings, and you know your correct unit of measurement is going to be seen. Let's do number 12. 12 says the receiving clerk had to send back, he sent back send back 6.5% of all produce yesterday. It is sent back 6.5% of all received yesterday because it did not meet specifications. If the clerk accepted, so the clerk, and they have it in bold, accepted 243.1 pounds of produce. How many pounds of produce did he originally ordered? Had the clerk originally ordered? So how many pounds ordered originally? Okay, so again, let's think about this. The clerk accepted 243.1 pounds of produce. So if that's the total that the clerk received or accepted, we have to figure out how much was sent back. Now, 6.5% represents how much was sent back. So we can put it this way, 6.5%, we can subtract that from 100. So 100% minus 6.5% equals 93.5% was accepted. Makes it a little easier for us to understand. We can use our other thought process that we used in the very beginning of this lesson. So we can have the total ordered be our x times 0.935 is percent accepted. And that would give us our amount accepted, which would be 243.1. Amount accepted. Now we can see visually what's going on. So to solve this algebraically, we would just need to divide by 0.935 on both sides. Divide by 0.935 on both sides. This would then give us x equals, divide by 0.935, 260 pounds of produce. So that's how much the clerk originally ordered, was 260 pounds. The clerk only accepted 243.1 pounds. And that would be your answer. Again, setting it up like this, we can visually see the algebraic equation on how to figure it out. Total ordered, so 93.5% of the total equals the part. That's the way I think about it. Is this is 93.5% of, remember, that means of, this is this. So these percentage problems can be a little tricky, but again, it's about wrapping your mind around the logic behind it, the concept behind it. When you get a hold of that, it makes things a little easier. Let's do number 14. You're expecting 50 guests for a brunch. Right, put all these notifications down. You want 50 guests for brunch. And you want to serve each guest 8 ounces of fresh squeezed orange juice. So 8, well, I'll put fluid ounces of squeezed orange juice. All right. Oranges weigh 7 ounces as purchased and have a yield percentage of 37.5% when juiced. Okay, so here, this one is a little different. We're going to leave this as just ounces. 8 ounces of squeezed orange juice. Oranges weigh 7 ounces as purchased and have a yield percentage of 37%. That's a pretty low percentage because we are juicing them. So juicing, we're only using the liquid out of them. We're not using any of the fiber or the skin, rind, whatever it is on the outside. So a very small percentage. It's asking how many oranges will you need to purchase. So how many oranges we need to purchase. Okay, so 50 guests, and each one has 8 ounces of squeezed orange juice. Remember, this number right here is going to be our EP. That's only our partial EP. We need to figure out what our total would be, and we'll need to do something with this 50. So we're going to say 50 times 8 ounces would give you 400 ounces, and that would be our total EP that we need. Now it says each orange is 7 ounces, and our yield percentage is 37%. So first we need to figure out what our AP is in order to figure out how many oranges we need. So we need to figure out our total AP. Again, remember AP times yield percentage equals EP. So our AP we don't know. Our yield percentage is 0.37. Our total EP is 400 ounces. You can divide both sides by 0.37. 400 divided by 0.37. Now it gives us an infinite number in the calculator. X equals 1081.081081, and it's going to keep going 081081. Store that number in your calculator and keep it there, because that's the number we're going to use to figure out how many oranges. That's our ounces, and that's our total AP. So it's 1081.081081 ounces, and we multiply that by 7 ounces on the bottom and then 1 orange on top, because then we'll be left with oranges as our unit of measurement. So take that number that you have stored in your calculator and divide it by 7. And you'll get 154.440154, keeps on repeating, oranges. Now, of course, we can't buy like a half of an orange. We have to buy a whole orange. So we would round this answer up. My math lab says round up to a whole number of oranges, but we want to think logically like why we do that. It's because we can't buy half an orange. We're going to have to buy one more so that we have enough. You don't want to buy two less, like 154. Then not every guest will have 8 ounces of squeezed orange juice. Then we each have like maybe 7.95 ounces of orange juice, whatever the number would be. Regardless, round it up, because you want to have enough ingredients for the entire brunch. That's how you break down that problem. Again, logically, think about what you need and how to get there. That's the process of all this math. So let's do one more. There's 20 questions within this homework. I don't want to do them all, of course. I want you to try a couple of them, but I'm trying to pick ones that are a little bit more difficult. Number 17 says a serving of carrot raisin salad requires 3 ounces of shredded carrots. So it requires 3 ounces of shredded carrots. So again, look at it, it's prepped. So that's probably our EP that we're talking about here, our edible portion. Carrots have a yield percentage of 81.3%. It's asking how many 5-pound bags of carrots should you purchase if you need to prepare 130 servings of carrot raisin salad. How many 5-pound bags of carrots for 130 servings of carrot raisin salad? All right. So we need to figure out bags needs to be our final answer. How many 5-pound bags of carrots for 130 servings of carrot raisin salad? So there's our total. We need to figure out our total amount. We need 130 servings. Each serving is 3 ounces. So 130 times 3 ounces. 130 times 3 would give us 390 ounces, and that's our total EP. Again, use the formula AP times yield percentage equals EP. And we can figure that out. We need to find out our total AP so we know how many carrots to buy. X times 0.813 equals 390 ounces. You'll have to divide both sides by 0.813. Divide by 0.813, and that gives us a repeating decimal again. X equals 479.70479.705. Goes on forever, but store this number in your calculator. This represents ounces. We need to convert that to bags, and this is 5-pound bags. So first gotta go to ounces to pounds, then pounds to 5-pound bags to carrots. So 479.70479.705 ounces times, for every 1 pound you have 16 ounces, and then we want to change that to bags. For every 5 pounds we have 1 bag. So that will tell us how many 5-pound bags for that last part, and that will give us our answer. Here it looks like the top numbers are going to be the same, so on your stored number, take your number and divide it by whatever 16 times 5 is. 16 times 5 is 100, or I'm sorry, not 100, it's 80. So this would be your long number divided by 80. So have that number stored in your calculator and divide it by 80 so you get a nice answer. When you divide it by 80, you get 5.996309. Now again, remember, you can't buy a fraction of a bag. You have to round up. So this would be about 6, and this is 5-pound bags. So we need a total of 6 5-pound bags for the recipe. And I kind of separate these numbers here so you don't mix them up as 65 or 5 pounds. We're talking about the number of bags. It's 6 5-pound bags. Each bag weighs 5 pounds. You got to get 6 of them. So in total, that'd be 30 pounds in total that you would need. All right, so that wraps it up for the percent applications. And there's a bunch of other problems for you to do. And I picked out a lot that encompass all the other types of problems. But the percent applications teaches you how to wrap your mind around something logically and how to understand it and set it up correctly. And you'll need this, for everyday life. Like, how do you rationally and logically come up with a solution to something? Next section, homework number 8, is over ingredient costs mainly. So it's mainly ingredient costs, tell yield percentage, AP and EP for an ingredient, and then how much it will cost to make a recipe, but for that specific ingredient. How much does this ingredient cost for this recipe? How much does that ingredient cost? How much is veggie oil for a recipe? Maybe like 2 cents. How much is some meat for a recipe? Maybe $1 or $2, depending on the type of meat, to make your recipe. That's where you get your food costs and everything. You have to make a recipe cost form. You then use that to calculate how much you want to sell that recipe for on your menu item. So everything builds on itself. We went over food costs as a preface to it, but now you're going to see how to calculate how much a recipe costs. And we use everything that we've learned in terms of yield percentage and our EP, AP to calculate our food costs. So after you do this and do homework number 7, go on and move on to homework number 8, lecture number 8 over ingredient costs.